We'll start from scripts. First script is setup, responsible for running the people's end. The purpose of the script is to execute the Docker command using the Docker Compose and initializes it. Docker Compose setup, such a Docker Compose files configure containers. Docker Compose file is used to set up the environment or restart the services with updated builds or configurations. This script is used for the let's fix this code. As you can see, it's running. Now I'm going to show the result of this running this thing. This is our local cost result. This is going to do. I'm going to stop this script by running on. And the second script is manage logs as such. Responsible for creating the Docker logs folder and setting log information to this folder. It collects logs and organize them into one specific folder for log file management. There should be a place to store logs, run, there. As you can see, there is this file. This one is responsible for storing the logs. This spreads directly for Docker logs if not only exists. Let's run this script. It's setting logs for lots of things. Those are the same specific file. Start script is not Docker as such. It will solve all Docker containers, eliminate all containers which have some images and the browser button. I'll not execute this code, but if, because it will stop.
Hello? Again. Desktop screen. Let's start. The fourth script, the next script, the fourth script, it's a bash with the name of monitor resource. And this script, it's very helpful to keep an eye on the memory, CPU, and the limit of Docker containers. And also it monitors how many resources Docker containers are using. As you can see, this Docker stats node stream, it shows the CPU and the memory use Docker container in a snapshot. And the script is used for monitoring the resources, given helpful information or performance tuning. Let's run the script, this bash. For this, we use this command. As you can see, the script shows the container, the name containers, the CPU, person, the mem usage, and the limit memory. And the next is Dockerization. It specifies all needs components, the volumes, networks, and the services that Docker containers will use. It concludes services, volumes, networks. Services, services describe the containers and the environment variables, volumes, ports, and the image with their configuration. So volumes configure and manage long-term data storage in containers. Networks builds containers to container connectivity. The next, fit to the Docker file. As you can see, its file automates the building of Docker images by specifying the dependency, environment, and the default run command. And as you can see in the run, we define the base image. In the run, it runs the commands in container. In the copy, we set the commands to run when the container starts. In the CMD, configures the standard command to execute upon container startup. That's all. I have finished.
Please, thank you, Yerassyl. Right now is my turn. So my part is mostly deployment. I'll explain how we did CI and CD pipelines. So let me show you. So for pipelines, we use it GitHub Actions. They have their built-in runners that will check our pipeline. So basically, it's works on every push commit on specific branch main. So we are using the system Ubuntu latest version. So every time an update is pushed to the main branch, the workflow is configured to automatically run the build and deployment procedures. It illustrates several custom tasks, including the steps to create, deploy, and configure the application environment. For deployment, we use GCP, Google Cloud Platform. For using it, we need special created service account with some permissions. We give owner permission, so it will have every access. And also secure permission allocation from GitHub Actions to GCP is made possible by a service account. Yeah, as I said, this is necessary so that the CI/CD pipeline can communicate with GCP services to continue working. Yeah. And then later during the deployment phase, we'll use it. So now we can see we have server project folder in artifact registry. So it's basically GCR, PCR.io. So in this artifact registry, Docker images and other build artifacts are stored in an artifact registry. The setting is required to control artifacts created during the build process. This registry is used by the CI/CD pipeline, which streamlines and simplifies the deployment process by providing the necessary artifacts for it. But how the pipeline is working, we can see it from here, in actions. So in every commit, check. You can see that it's working. Every phase is successful. Finish it. Just check out this whole pub authentication, image builds, pushes, and configure Docker client, and etc. So that's all.